Hello ho ho, and yeah, welcome back to Matplotlib, welcome back to Python, welcome back to another part of the Matplotlib tutorial series. And yeah, I hope you had a wonderful Christmas time, and yeah, let's get back to Python and to coding. Yeah, today we are looking at 3D wireframe plotting, which means it's a little bit similar to the surface plotting, but yeah, instead of a surface, we also have a surface, but yeah, it's not defined by a simple surface, but more of little wires or little lines that define different squares. So you have these little squares, and it's hard to explain or hard to describe. Maybe it's easier if I just show you by coding. So let's dive just into it. We need we are using this ones from mpl underscore toolkits point mplot3d or mplot3d import access 3d. And yeah, for Matplotlib, import pyplot. Usually we are using from Matplotlib, import Matplotlib as MLP. But yeah, today we are trying it a little bit different. It's a little bit boring if we are doing it the same time each tutorial. So yeah, we are doing it like this. And yeah, but you can do it similar to my last videos. But yeah, even if you do that, you should add from MPL toolkits, you should add this line. And yeah, pyplot.show, just for the case that we forgot it and are confused why he isn't showing us anything. And yeah, now let's use pyplot.figure like we used in our last videos, but you may be surprised, this time we are kind of using that instead of just typing it. So yeah, we are using fig. First we declare an object which we call fig. Now we are using fig point add subplot, giving it also a name. Let's call it namey equals fig.add subplot. And now we are having a number or an integer consisting out of 3 different digits from 1 to 9. We can't use 100 or 101 and so on. It has to be at least containing 3 ones, no 0, and can get up to 999, but yeah, we want 111 because that's a little bit complicated, but in a kind of different way. We have our position of our subplot because we are working with a subplot, and 111 means just position 111. So he is automatically using the first position and using the entire space of our graph for this position. So let's just show it. Here we go. If we are using 1 second, you can't see it. Here we go. This is if we use 111. Now let's use 122. Stop and return. And now it has a different position and so on. But we are using 111 as a first argument. Second argument is projection. And equals a string. This string is called 3D. Now if we run again, we have our little surface we know from our previous videos. Now, and that's important, we are doing something we didn't do before. We are using defined or predefined values for our x, y, and z axis. So we get a surface we can work with, kind of representing a mountain. And for that, we are using the MLP toolkits. So we are defining x, y, z. We don't need that spaces, I guess. Equals x 3D point get test data. So what does that mean? Let's print it. Print x, print y, print z. And yeah, let's restart it. Figure should be pretty much the same. But now we have a console. So now you should see the console. And yeah, we get values from minus 30 to 29.5 and get values from minus 0. And not that important. What is important is this are two-dimensional arrays, so we have this arrays inside another array, so they are two-dimensional. That's important for creating our surface, that we are using three two-dimensional arrays pretty much, and they have to have the same size. So what we wanna do, we want to create a wireframe based on these values. So don't need to print it anymore, but we are using namey point. Let me think, how was the name of the function? Oh, I looked it up. It was plot wireframe, taking arguments like you may be expecting that x, y, z, then erstweit and seestweit. Erstweit, let's say equals 2, 1, let's say 3, and seestweit equals also 3, and color equals green. Come on, green. And now let's try it. Got an error in my console. Keyboard interrupt, okay. But even with this, we have an exception, but nonetheless, we have our little graph, our little plot here. Can see it. This is what I mean with squares. We have the surface containing different squares, and squares got larger, or let's say longer, when we are adding surface or when the mountain gets higher. And kind of interesting. And what we wanna do, we want to use different data, because this is let me do it smaller. This is predefined data, and we want to let's not create our own data, but let's alter this a little bit. Let's just alter the x-axis. Let's do x equals xx xx for xx in xi for xi in x. So let's just check. Okay, by the way, before I forget to mention that, we need numpy to import numpy now. Import numpy as np, because this has to be a numpy array. Otherwise it won't work. So now let's try it. Will it work? Yeah, pretty much the same, but yeah, that's what we wanted to see. I guess he is, yeah, should be nearly the same. And what we are using now is we are using xx plus np point random point rand. Oh no, let's use a rand integer. Gets us a random integer between 2 and, yeah, let's say 5. And yeah, let's try it again. And now it looks a little bit eldritch. Kind of interesting. Because, yeah, on the x-axis we added different values, which just adds some, yeah, some interesting variations. By the way, the console is not needed anymore. I will close it. And yeah, you can see it now. Oh, what did I do? Okay, that's interesting. This was not my intention, so let's restart it. Just wanted to zoom a little bit. Like this. Now I zoomed. Yeah, you see the values need some wires. But yeah, let's create another one. Now rstride and cstride defines the frequency of the lines. So let's use some higher values like 9 and 9 to add some frequency. Oh, I'm totally stupid. The higher the value gets, so yeah, this is better. And for that we need to zoom a little bit. So let's use the zoom. Let's zoom again, and again, and again, and again. Yes, looks like a spider web, but more like a spider kingdom. But I guess everything is connected. So if we add, yeah, let's use cstride. Let's use higher values for c and rstride. No, I don't want to exit. Let's use 6 and 6. It's, by the way, the higher the values for cstride is, that easier it gets regarding, yeah, moving it, because you are kind of wasting memory and CPU if you're having too much lines. So this is much easier, so it is not everything is connected. Yeah, but as you can see, it got a little bit kind of funny what the design is. Now let's do the same for x and y axis, for z and y axis. Y and z. Y and no. Y and z. And yeah, just gets more abstract, or as you can see, nothing much to discover regarding that. So let's delete the line from 1 and let's look at it again. Now you see the lines of the, I guess, the x-axis disappeared. And if we zoom in, we see it's just one-sided. Yeah, instead of using of visualize data, we are just creating eldritch abominations. But I like to create eldritch abomination, and with that in mind, I don't even know if we have other topics to handle regarding Matplotlib. Maybe this is the last video regarding Matplotlib and I will head to another project. But yeah, apart from that, maybe goodbye regarding Matplotlib, and I wish you a wonderful evening, nighttime, dinner time, whatever time it is in your country. See you and bye bye.